All right, I'm gonna try and follow that up. Mine is not about fish, not nearly as exciting. So this is a project from my undergrad that focused on surface coal mining in the Appalachian region, specifically Boone Barber and Logan County. I was really passionate about environmental justice, so I was focused on if there was any correlation. I didn't really do any deep analysis, so obviously nothing significant will come out of this, but mostly just like a surface level exploration of trends that I was seeing. So just a tiny bit of background. This will be very basic, but so we know that coal has been a primary source of electricity generation, and then it's decreased significantly, especially production in Appalachia. Looking at regions, the figure on the right shows mostly central has decreased tons, and that's like southern West Virginia and Kentucky. But even though there's been a huge decrease in production, there hasn't been a huge return in pre-mining forestation and hydrologic conditions throughout the region. So this is a huge issue that Appalachia is still facing. This is a 65% decrease in production. I'm sorry. So diving deeper into that, mountaintop removal, as you all know, is one of the most popular methods for moving coal in the Appalachian Basin. But we know that it's highly disruptive and harmful to aquatic and terrestrial ecosystems. It displaces vegetation, alters subsurface and surface topography, and modifies water and mineral transport. When mining occurs, this process emits and transports carcinogenic byproducts directly into the atmosphere and waterways through drilling, blasting, overburdening loads, transportation, mismanagement, even mine fires, and when the mine is abandoned, it can still travel. So this is just a huge public threat to health. We know that it causes lung damage, irritation, chronic inflammation, asthma, pneumonia, lung and bronchial cancer, things like that. Images on the left are just environmental impacts. One of the biggest surface mining complexes in West Virginia on the top, and just acid mine drainage on the bottom. Looking at West Virginia specifically, there's a stat that says that around 30% of West Virginians live within a mile of an unreclaimed mine site. This was kind of the focus, what drew me in to West Virginia specifically. And West Virginia has the second highest lung and bronchial cancer incidence rates. This is per 100,000 people in the United States. The map on the right is all of cancer mortality in the United States, and you can see that this is clustered around Appalachia significantly. That's 2014, but this is still what it looks like today. I do want to acknowledge that there's a lot of socioeconomic factors that influence cancer mortality and incidence, but I just wanted to explore trends, that's all. Yeah, and we do know that there is some proximity related, like the proximity of populations are related to these respiratory and metabolic diseases. So how do we fix that? We all know that reclamation is a huge way of returning the land to its previous state. Also fixes some public health issues there. But West Virginia has really struggled with these programs. We see a huge mismanagement of these programs, underfunding. But recently, West Virginia did receive $140 million, and I think another $27 million in the last 2 years. This is reflected on their website as well. They have a few contracts going, and hopefully we'll see some improvement. I would be interested in reviewing newer imagery on the mines and seeing if they've improved at all. But that being said, so my project, I just wanted to focus on what monitoring mine activity through remote sensing could tell us about surface mining legacy effects in Appalachia. I chose to focus on only 3 variables: mine area, mine production, and lung and bronchial cancer incidence, and just any noticeable trends or patterns there. So specifically, I limited my study to just 3 counties because I only had like 2.5 months to do this work. But the map on the left is just the 3 counties pulled out, and the surface layer there is surface mining. It's an attribute layer from West Virginia Geologic Survey, I believe. It's public. And so these 3 counties, they all had pretty high LBI and mining presence, which is why I chose them. I chose 2015 through 2016 because that was when cancer reports became available. And then I focused on July and August because these are the highest tree canopy and vegetation growth. This is just data catalog, but I went through cancer registry reports and West Virginia mine safety and health reports looking at permitting, production, things like that, cancer incidence, and then grabbed imagery from Landsat 8 and Landsat 5 for 2005 and 2016. For cancer data, these are given in rates for incidence, so 2005 to 2009, 2009, 2020, 2013, and 2012 to 2016. I acknowledge that there's some overlap there, but since I was messing around, I wasn't too concerned about that. I also was looking at the permits or production rates, and those don't start until 2007, so there's a little issue there as well, missing 2005 and 2006 data, but I was just extrapolating a little bit. So starting out with my method, I did a GIS-based approach to this just because the resolution was so different between the 2 years. I compiled the images in ArcGIS Pro, clipped the counties to their boundaries, and used a supervised image classification with a training sample and maximum likelihood. I also just georeferenced this, like the most basic georeferencing through Google Earth and that surface layer I showed in the past. And on the left is just a footprint of the imagery. I think that would be Barber County. I made a ton of assumptions here. I only had 7 classes, and these classes are defined pretty barren. Like developed was most reflective surfaces, roads and buildings, forest as detected vegetation, mines as known sites, barren as less reflective sites, and oh my gosh. And cloud, obviously cloud cover, shadow as cloud-produced shadows. And I also assumed that all mines were operating under a Department of Environmental Protection permit, and they were therefore reporting their coal production. I don't think this is the case, and we'll see that later, but that's another issue with all this data. So going into it, I found that LBI rates decreased significantly from 2005 to 2016. Greatest improvements are in blue and cyan on this map. I could have visualized this better, but I did this like a year ago. You can see that Barber, Boone, and Logan County are all within these 2 categories, which is great. It means there's significant improvement. For the state as a whole, it also decreased significantly. It went from 116 per 100,000 to 93.6 per 100,000. But just as like a note, the national average is around 56.3 per 100,000, so West Virginia is still lagging quite a bit in LBI. Looking at surface coal production, we see a huge decrease in Barber. They stopped surface mining according to their reports in 2012. Boone County significantly, 91%, and then Logan a little less, 84%. Like I said, Barber, since they didn't report anymore, I assume that there were no more surface mining permits being given out, but I don't know if that was actually the case. Looking at land cover change, this is just Boone County's for an example of how it looked, but for decreases in mine area, Logan was pretty significant at 59.6% decrease, Boone at 27.2%, and Barber, once again, not sure about that because of the mine permits, but assuming 100%. Looking at the trends in data, we can see that they all do decrease significantly. Obviously, mine area much less just because of the scale there. But LBI rates are in blue, mine production in dark green, and mine area in lighter green. And then on the right, by county, we see that Boone experiences the largest decrease in LBI through the time period, as well as, and then Logan coming in second there. I can't run a significance test with these because there are only 3 counties. If I were to do this again, I would add more and would definitely run some more tests on that. But I did find it interesting that they do seem to trend more with intensity than area. I initially thought that more area would mean more impact, but mine intensity has become a focus in literature. It seems like they're looking at that especially in low resilience ecosystems. And I don't know if people have read the Pitt School of Public Health study on fracking that came out in July and August, but they also look at fracking intensity as opposed to just fracking areas as a big cause of childhood lymphoma rates. So I thought it was interesting. And just to conclude, so yeah, both mine area and production decreased significantly, and LBI does lag quite a bit in these areas. Mountaintop removal legacy effects are probably not as linear as I was expecting, and remote sensing is a great way to view reclamation throughout these mines. And mine intensity could be greater explored for these kind of projects. In the future, I'd also like to look at involving communities, maybe through like a behavior analysis, and just seeing how that would impact lung and bronchial cancer. But otherwise, that's that. If anyone has any questions. I'd also like to acknowledge Energist for the scholarship, and Just My School and my professor, Mike Ramsey, for helping me with this work.